Good afternoon, everyone. My name is Vanessa Hawkins, and I'm here today with my colleagues Victor Rodriguez and Yussimil Libera, and we will be reporting on self-driving cars. So first of all, what is an autonomous vehicle? It is a vehicle that can sense its surroundings to navigate the roads without any human interference whatsoever. So the problem statement here is to conduct research that will aid in the development of a vehicle that can avoid collisions and perilous situations, decrease fuel consumption, eliminate traffic violations, increase speed limits, and improve human productivity during the driving experience. Our motivation for this project and research was really to gain a better understanding of autonomous vehicles. We did this by analyzing past shortcomings throughout history, as well as determining industry next steps for a fully autonomous vehicle. So there are actually 5 levels of autonomy, and these are determined by the National Highway Traffic Safety Administration. So level 1, driver only, is a vehicle that can drive under human control completely with only assisting automated systems to help the driver. Level 2 is driver assistance. Here the steering and acceleration are automated. However, it is expected of the driver to take control of all other functions. Level 3 is partial autonomy. Here the driver does not control steering or acceleration whatsoever, but he is expected to be attentive during all times of the driving experience. Level 4 is where we reach the higher levels of autonomy, and this is high autonomy. So the vehicle operates autonomously for the majority of the portion during the journey. However, if there is a perilous situation that occurs, the control is transferred back to the human with some forewarning. Level 5 is the step that most auto manufacturers wish to attain in the future, and this is full autonomy, and the vehicle is capable of driving itself unaided for the entire duration of the journey. And it is expected that the car can operate without a human within its vicinity. So just a little historical background on AVs. They first emerged in the early 1920s, and they were often operated by radios or wires that were embedded or buried within the pavement. The first vision-controlled AVs didn't occur until around the 1980s, and we still do use vision control today. However, they are aided often with sensors.
As my teammate already provided an overview of the 5 levels of autonomy, I'm going to go a little bit more in depth into what level 1 and level 2 entails. As you can see in this slide, level 1 stands for driver only, and what that pretty much means is that the vehicle is completely dependent on the driver, so pretty much more than 98% of the functions are managed by the driver. Of course, this includes and it deals with the steering, the brakes, the throttle, and the power. At this level, these are the most common vehicles, the vehicles that we're most commonly accustomed to, that we see every day and that we probably drive every day. At this point, it pretty much only has cruise control, and then it provides warning and signals in case of anything it's going incorrectly within the car. Level 2, of course, is a little bit higher in the scale, and the names of it, or the title of it, is the driver assistance level. And one of the cool and most important features on this level is the electronic stability control. So at this point, when you're driving, in case the vehicle experiences a sharp turn or anything of a quick response, what it does is that it controls the power provided to the 4 wheels in order to account for this effect, for this situation, and avoid a possible impact, and at the same time provide more of a smooth driving capabilities. Of course, it has parking assistance and automated steering, and also a little bit about the history of this level is that it initially started using radar and lasers as a form of distant measurements to avoid impact. So what it would do is that once it noticed that an object was at a not safe distance, it would automatically push on the brakes, so it wouldn't give the driver, when this first started, it wouldn't give the driver a chance to decide whether to stop or not. So sometimes it could have an incorrect, it would sense an incorrect object or incorrect situation, so it would definitely also have an undesired effect. So what we're currently using right now is the sensor. So the sensors they notice the object at a safer distance. So what it does is that it allows the driver to have some time to decide whether to stop or not. And then in case the driver doesn't provide any feedback or answer, and then it crosses past the line of what is considered as a safety distance for the vehicle, then the brakes are automatically applied. As I said already, even though it is a little bit high in the scale, it is still driver dependent for the remaining of the functions. National Highway Traffic Safety Administration has stated that if the features were to be included in auto or everyday vehicles, then 1/3 of the accidents could have been reduced or avoided. And now I'm going to pass it on for my teammates to elaborate on the other levels.
So moving on to level 3, which is partial autonomy, the vehicles would then integrate 3 types of main sensors, and these include ultrasonic sensors, radars, and forward-facing cameras. The Tesla Model S is a great example of these implementations, and as you can see, ultrasonic sensors are being used vastly. There are 12 in the front and the rear bumpers to detect any obstacles that are close around. The radar is used to emit waves that bounce off nearby objects or obstacles to avoid them. And the forward-facing camera is used to detect or read any traffic signals such as stop signs or speed limit signs to follow the traffic rules. Moving on to level 4, it is a higher level of autonomy, and it is considered high autonomy. An example of this would be the Google car, as it has all of the features that the previous levels have, and in addition to this, it also has a LiDAR laser sensor, which can read 360 degrees around its vicinity. So to go more into detail of the LiDAR sensors and its other features, Victor will discuss the features of the Google car.
The Google car is also a great example of fully autonomous vehicle. And we have to have something clear. For a fully autonomous, what the car needs is to sense everything on its surroundings. And to accomplish this, one of the main features is the LiDAR laser. The LiDAR laser creates a 3D map around the car and tells the car what distance it is from its surroundings. Also, this car has a front camera that its main goal is the ability to read road signs and gather all that information. Also, it has the bumper mounted radar that it is used mainly to establish a distance, a safety distance from the front vehicles and the rear vehicles. What it means is depending on the velocity of the car needs to get a safety distance in order to be able to react to obstacles or, for example, the car in front stopping suddenly. It also, of course, will have geolocation and these ultrasonic sensors on the back rear that are very important for the parking in tight spaces. Of course, it will have altimeter, gyroscope, and tachymeters that will determine the precise position of the car, also the inclination and the impending motion and direction of the car. The future of the autonomy is said by scientists is that it's not actually on the technology. The technology is said to be already invented. It's in the interconnection of the cars and how they can share information that has been read for sensors to car, and this can prevent a lot of collisions. For example, in case of failure of sensors, one car can transmit the information of its surroundings to another car, and this can take the measures needed to avoid any collision. You see, the future is not far away. The main manufacturer has scheduled a fully autonomous vehicle for the present years, so I think the future is bright.
To pretty much put everything together, the automotive industry has gone a long way since it initially started in the early 1900s. From AV being initially controlled by radio signals and underground circuits to presently being able to receive GPS guidance and voice recognitions and a variety of sensors to avoid accidents and impact and unexpected road conditions. And as explained previously, the autonomous vehicles comes in several levels of preference in this way to help the driver feel comfortable with the AV features without having to compromise with other. From level 1 to level 5, they control only the brakes and provide impact avoidance feedback. To level 3, where the vehicle controls the acceleration and steering. To level 5, where it is completely autonomous and does not require the driver to be at all within the vehicle. Even though autonomous vehicles represent a really safety and comfortable alternative, and they're still not able to perceive crucial situations such as, for example, a bicyclist at the side of the road or unexpected weather conditions. It still requires definitely there for more years of study or research and testing to optimize on the best solutions for these cases. The future does look optimistic though. For example, one of the ideas is to have the cars communicating with each other, as my teammate had already explained, and as an additional precaution, and at the same time a 360-degree camera that will be able to preserve the entire surrounding. Thank you so much.
Thank you.
Thank you.